Okay, the last video to prepare for the retest is just a really quick review of the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. Remember, these were the two special right triangles that we talked about. And they had specific relationships. For example, in the 30, 60, 90, the length of the hypotenuse is equal to 2 times the length of the short leg. The long leg is equal to the square root of 3 times the short leg, and then 2 times the long leg is equal to the square root of 3 times the hypotenuse. You can see by our little moose over here, he has this confused look and a right triangle on above his head. The relationship is 1, square root of 3, and 2. So when we look at example 1, all we have to do is remember our relationships, and we can solve that for x and y. X is the short leg, so the relationship between the short leg and the long leg is that the long leg, 12, square root of 3, is equal to the square root of 3 times the short leg, which is x. To solve this for x, you'll divide both sides by the square root of 3. These will cancel, so x is equal to 12. So you have the short leg. Then you just need to look at the relationship between the hypotenuse, y. That is 2 times the length of the short leg, which is 12. So y is equal to 24. So in this first example, there's the x and there's y. In the next example, this time I'm given the hypotenuse. Remember, the relationship between the hypotenuse and the short leg is that the hypotenuse, 24 square root of 5, is equal to 2 times the short leg x. To solve this, you're going to divide by 2. Okay, these cancel, so x is equal to, now remember, on the left-hand side, we're just dividing the coefficient by 2. So this becomes 12 square root of 5. That's the value of x. Don't divide that radicand. There is no radical on the denominator, so you cannot divide that. Now the long leg, y, is equal to the short leg, 12 square root of 5, times the square root of 3. Remember, when we multiply these square root symbols together, we multiply what's out front together. So 12 times 1 is 12. And then the radicands together, 5 times 3 is the square root of 15. So there's my answer for x and my answer for y. And just leave those. That is simplest radical form for both of those. The last one we're going to talk about on the packet is number 3. And again, it's a 30, 60, 90 triangle. The relationship between the long leg, y, that's equal to the short leg, 3 root 2 times the square root of 3. Multiply the coefficients together. Sorry, in this case it's a 1. Let me erase that. I don't like the way that looks. That's a 1. So you're going to get 3, then the radicands together, times the square root of 6. So the long leg, y, is 3 root 6. The hypotenuse, remember, is the short leg, 3 square root of 2 times 2. Now this time, I don't have a square root symbol in the second part, so I just multiply those integers together. 3 times 2 is 6, square root of 2. So that gives me my value of y, and my value for x. Now there are 3 more problems in the packet for you to finish that deal with a 30, 60, 90 right triangle. So the next one we're going to take a look at is the 45, 45, 90 isosceles right triangle. And the relationship here is that you have 2 congruent legs, so they are the same length. So in this case, x is equal to 7 because it's a 45, 45, 90. Base angles are congruent, so those legs are congruent. And then the relationship between the hypotenuse and the leg is the hypotenuse y is equal to the leg times the square root of 2. So that's the relationship for the 45, 45, 90 isosceles triangle. We're going to do another practice problem. This one looks a little more complicated. It's really not. You just have to look at it in pieces. So the first part we're going to take a look at is I have this 30, 60, 90 triangle here, which I'm going to be looking at. And then I have a 45, 45, 90 right triangle over here that I'm going to be taking a look at. In either case, I have that long leg or the leg. So if I choose to first look at the 30, 60, 90 right triangle, okay, then this A is the short leg, B is the hypotenuse, and 3 square root of 6 is the long leg. So I've identified the legs. I know the relationship. The long leg, 3 square root of 6, is equal to the short leg A times the square root of 3. I'm going to solve this for A, so I'll divide by the square root of 3. So I have 3 square root of 6 over the square root of 3 equals A. Now remember, I can write that as 3 square root of 6 over 3, and I can simplify that radicand at that point, and that will give me 3 square root of 2 is the value of A. Sorry. So 3 root 2 is the value of A. Then the hypotenuse, B, is equal to the short leg, 3 square root of 2, times 2, which would be 6 square root of 2. So now I have found the values for the 30, 60, 90 right triangle. Let's take a look at that 45, 45, 90. Remember, the legs on a 45, 45, 90 are going to be congruent, and therefore C is equal to 3 square root of 6. The hypotenuse, D, is equal to the length of the leg, 3 square root of 6, times the square root of 2. And again, remember, we're going to multiply the numbers out front together. There's a 1 there, and then the radicands together. So that's going to give me 3 square root of 12. Now, this case, I recognize that 12 can be simplified. So D is equal to 3 times 4 times 3. So that becomes 3 times the square root of 4 times the square root of 3. So I have 3 times 2 times the square root of 3, which is 6 root 3. I don't know what I wrote there. It looks a little confusing. That 12 is 4 times 3. So I know that C is now 3 root 6. And when I'm looking for E, E is equal to A plus C. So E is equal to 3 root 2 plus 3 root 6. Remember, these radicands are different. There's no way I can make them be the same. So therefore, I have to leave them exactly as they are. I cannot simplify that any further. A few more practice problems on these special right triangles. Okay, again, B is a leg. The legs are congruent in a 45, 45, 90 right triangle. The hypotenuse A is equal to the length of a leg times the square root of 2. So in this case, 2 times the square root of 4. Square root of 4 is 2. 2 times 2 is 4. So in this case, A is 4. Number 2, again, the legs are congruent, so x is equal to y, which is equal to the length of the hypotenuse divided by the square root of 2. Now I have a radical in the denominator, so I have to rationalize that. That becomes the square root of 2, square root of 2, so that becomes 4 root 2 over 2. You can simplify that to 2 root 2. Number 3 looks a little trickier. I recognize that y is the same because they're both legs, 3 root 2 over 2. But now to find x, I need to take the length of the leg, 3 root 2 over 2 times root 2. And if it helps, put that root 2 over 1 so you recognize you're multiplying those numerators together and you're not multiplying that denominator. So this becomes x is equal to 3 square root of 4 over 2. That's 3 times 2 over 2. They cancel, and that becomes just 3. Number 4, again, y is equal to 3 square root of 2. X is equal to, then the leg, 3 root 2 times root 2, which gives me 3 times the square root of 4. Square root of 4 is 2, so x is equal to 6. And that's the last video to prepare you to take the retest on section 8.1 and 8.2, special right triangles. Once you turn in the paperwork, you can schedule the retest. Thank you.